So what I'd like to do first is trigger a discussion. I want me to talk less than others of one thing I've been involved with here in Santa Barbara for many years, and less so now, is an engineering academy where we really got the students doing hands-on learning again. So I'd like to hear stories for anybody who wants to tell a brief story of experience with the need for or how to achieve hands-on learning, because your machine shops are probably gone. So I'm going to shut up and see who wants to start. I have someone here too. Okay. Well, hang on a second. Let's let Gail go first. Go ahead. Please. Hang on, just use the microphone.
I'm sorry.
I disagree that the machine shops are gone.
Good.
Because I know where my daughter teaches at a...
Where are you from? Say where you're at. What's home for you?
I still live in New Jersey.
Okay.
But my daughter teaches at a prep school in Massachusetts, and they did complete renovation for her because of her robotics team. Mm-hmm. And you'll see many schools have put a lot of money into, they're calling them STEM rooms or STEAM rooms. Mm-hmm. I think the STEAM has art involved. So I believe the fact that machine shops are, well,
changing.
They're not gone.
Good.
They're changing.
Okay.
I think that's true. The story I was going to tell is from Minnesota, not from where I'm now in New York. But still, that sometimes raises questions. What if the machine shop won't do, or if the student has a project that extends far, far out, right? So I had a student who was very interested in doing something about the Casimir effect, inspired by one of the conferences here. And it was a case of, like Rutherford, right, that you can't build that apparatus, you have to use your brains. And she came up with a model with just a fish tank and splashing water and so on. And, maybe it wouldn't pass muster, for Laura's talk or something, but for a student project, it was great. It calls for more ingenuity and more work, and I think puts a lot more weight on the students, but it's still done, it's still possible.
I think I know in California they have what are called California Partnership Academies, and which is probably the one in Santa Barbara, Project Lead the Way, where they're doing a lot of hands-on stuff. We are trying to reconfigure our physics program to make it much more parallel to NGSS curriculum. I think you just have to decide to do it, and hopefully money shows up to make that happen. But again, we're trying to do it, so
I didn't
baby
mean
steps.
And do a critique. I was hoping more to get stories going amongst each of you.
Well, we do hand make stuff in physics. We make them do things, but it's not something that is consistent throughout the entire year. It's more like a one-time thing, but
okay,
it works.
Sometimes I play devil's advocate a little bit. I just the idea of the flipped classroom is really funny to me, because it seems like that's what we've tried to do all along. We just called them books, and we asked the students to read them, and we found that the problem was that they didn't read them. Right. But I did a session at the University of Washington. That was the physics education group there. Does some really cool stuff. But I think fundamentally you can either teach physics content, a lot of content, teach students about physics, or you can have them sort of learn what physics is like and do physics in some sense. But there's not enough time to do both. Mm-hmm.
So can you speak a little bit further about how you handle that challenge?
That's evolving. I'm trying to more and more weave content in with a little bit of history as far as some of the major experiments go. And then I'll do some units in a very exploratory way, like I do a big circuits unit that's that way.
And this is at what level? With
These are 10th graders taking AP Physics 1.
Okay. Gail, do you have one additional comment, and then
Yes.
behind you, Kevin. But go ahead, Gail, please.
I'll go.
Yeah.
I always try to start my year with a particle physics unit. And I have students, one of the places has printouts of the actual results. And I said, well, I want you to look for this because that's going to be a boson or whatever we were looking for. And all the students were so excited about doing that. One of them in their debrief wrote, I felt so much like a scientist. And as far as content or hands-on, you can't pretend they're just not reading their books. We're in a new year, a new era. So, and the whole one program of physics says all you use your books for is to make ramps. So, you just have to come up with
Please.
comfortable.
We've got about 3 questions in the or 3 comments in the back.
I've got the future in mind. I'm working with 3 schools in San Bernardino City. The zip code for these 3 schools, the average family income is $11,000 a year. Kindergartners are learning coding. By 3rd grade, they're doing CAD-assisted design using SolidWorks. All of these schools have 3D printers, laser cutters, lathes in them. These kids are doing these kinds of things at a very early age. They're designing, it's all project-based. They have to pass the state standards like everybody else does, but there's no 8 to 9 reading, 9 to 10 arithmetic classes. By the time they get to middle school, they're designing things and creating them. At the high school level, that's part of this chain. They have 2 academies. One is a machine and manufacturing academy. The local community has brought in industrial size machines that have supported this. These kids are learning, they're graduated from high school with skills that are recognized by industry. And they're doing this, it's not just the physics, it's everything is involved. The math teacher and the English teacher and the history teacher are all part of this. And these kids in a lot of cases are not learning physics chapter by chapter, but they're learning these as tools. Now, they miss the kind of stuff that we get to do here.
Can you say a little bit about how all that came to be? How others can...
By some very visionary people at the top, the superintendent of the San Bernardino City Unified School District simply said something needs to be done. The graduation rate at the high school level was 37%. It's this year going to be 82% in 4 years of bringing these programs along. And as we see these kids coming up, and what it started was a group of teachers within a school said, we need to do something different. The principal said, go out and find out what. The district provided some money. Community people came in with more money and said, this is for you guys to go out anywhere you think you can find information. Bring it back. We'll incorporate it. We'll revamp our schedule. We'll revamp our entire curriculum. And then again, more and more community money has flowed in because the people see that this is something happening. It's not if we give you a machine, what will you do with it?
How many teachers are involved? What's been your experience with the how it's worked over time? Sounds like it's been existing for a long time, given what you're saying.
Well, it started with the elementary school. It started 4 years ago. They told the teachers we're going to start revamping everything. If you don't want to continue, if you don't want to move into this new system, we'll transfer you to another school, no loss of seniority, etc. 3 teachers left. At the end of the year, 2 of them wanted to come back, but they couldn't because nobody was leaving. There have been some teachers that are much more reluctant because they like teaching the standard process. But as they see what's happening, it's more interesting for the teachers. The success rate has gone up. Parent involvement is much higher. And they're seeing that the kids are surpassing the state level now while doing these things that are much more engaging.
Mm-hmm. That's wonderful. I think there's two more in the back, and we'll come around.
At our school, it's not quite that spectacular, sorry. But, one thing that we do is a few things that we do. One is we have a really strong science Olympiad and a robotics program, so there's after-school kind of possibilities for building. And also, after the AP test, we have about 6 weeks of school, and so we do a lot of independent projects then in all of our AP classes a lot of them involve building. The other thing that's happening at our school is we're doing a rebuild of the school, and we're going to be, the science department's going to be next to the shop area, so we're hoping the new kind of just a physical layout is going to allow a lot more kind of interactions between the shop and science. So it's in Bellingham, Washington.
There's one back here still.
I teach at the Connecticut Technical High Schools in Hartford, and we're 13 schools, about 10,000 students-ish. And the advantage with us is I teach science, but I also have an entire technical. The kids don't come to me to learn science. They come to learn plumbing and heating and auto body and CAD and culinary and all the trades. So when they walk out, they have jobs. But what we've done, what the superintendent started about 5 years ago, was a true interdisciplinary approach where our job now as a science teacher is to go into all of the different trades. Sit down, see what they're doing, find out how that can then be linked into what we're teaching. And it was difficult at first because you had to really let go and you had to truly grab this less is more philosophy, which in the world of testing is so hard to just embrace, because if they don't get something, then you're toast. But over the past 5 years, we found that it's really, the kids have embraced it, and it's been really successful.
That's great. Did you have something? Hang on a second.
For several years, I taught an integrated math and physics class in Lexington, and the idea was to get all of the kids who had bad experiences in science, perhaps in math as well, together so that I team taught it with a math teacher, and we did, mostly it was reviewing all the math that they should have known by this point and putting it to use. We had them do all sorts of projects all year long. And at the end of the year, these are seniors, and they are just ready to be gone and out from school. So to keep their interest, we did a project with rockets, where they had built Estes rockets and put an egg in it to see if they could get the egg to go up and come down without breaking. And they use little force probes to do an impulse curve and then calculate the impulse and predict the height that they thought that this thing should get. And it gave kids that just will perhaps be the ones that go out to get jobs building houses or doing auto mechanics a chance to see the type of connection between the mathematics and physics, the sort of scientific pieces that they had just completely turned away from by that point at high school. Anyway.
Yeah, that's great. It's a great story.
We were just talking about if you don't have a lot of the hands-on stuff, we do all the regular labs and traditional things, but they did get rid of our wood shop and that type of stuff. But Galileo didn't have advanced technology or equipment, so thought experiments are important as well. I have whiteboards and have students draw models, so I just did a lenses law demonstration, and you drop the magnet in the tube, and I used to just ask them, okay, what do you think's happening? And now I had them draw on a whiteboard, draw the tube, draw what you think's happening. I was really surprised by how many students had like positive and negative charges sitting there attracting the magnet. So that brought forward good discussions about the difference between magnetism and magnetic fields and electric fields that I wouldn't have thought of had I not seen all their models, including that, because we just got done with electrostatics, so it must be that. So models and thinking, and I also got the idea from people in industry that it's important that we have failed labs, because in high school typically all the labs are pre-set up to have the expected outcome, and then people get into industry and don't know what to do when something goes wrong. And so we should lie to our students, is what I was told by a chemist in Nashville. We should pretend that it should turn pink, and then when it turns green, they have to figure out why.
I guess along that line, I think I really appreciate what you said about, are we asking students to do science, which is what actually, when you have a failed experiment, most of the time, if you're trying to do what they're doing at LHC or any of that, you're looking at all the failures to point towards some kind of answer. But there's a mix between the knowledge, right, and the doing of a scientist. And that's why I appreciate also the rocket. What we do at the end of our 8th grade is we build a maglev train and talk about fields, because I want them to think about action at a distance, how gravitation, electrical and magnetic fields have something in common, that there's something in time space that we can't see, and then put it to practical use, how a drag and all of that. Also transportation, because I want them to ultimately think about big world problems, and that some of the stuff that they're getting in their physics class is applicable outside of a bunch of labs that are canned. But I think along that same line about labs, so many of my great students know the trick, which is to try to figure out what the answer is that you're supposed to get, and then make the data fit that, which is a dang good student skill, but not a very good science skill, because we're teaching to some knowledge instead of teaching to some experience, and that experience has so much. But we want to hide all of the error, all of the mistakes that come up, because, so I think teaching mistakes, teaching errors is essential.
Looks like we have a comment here on the right first.
I just want to add to everything that everybody said already. First of all, I'm so glad your kids are doing coding in kindergarten, because ours do it as well. I teach in an all-girls school.
Where are you from?
From New York City.
Okay.
We're doing 3 different things. First of all of our science curriculum is being moved to inquiry-based labs, because, as we say to the girls, when you get in the real world, nobody's going to give you a handout that says, here's your procedure and here's what you're supposed to do. 2, we're moving away from textbooks almost completely, because we're trying to curate content for students and having the students actually do that curating. Because our argument is, again, when you get in the real world, no one's going to give you a textbook and say, read chapter 7, answer number 1 through 4. We're also building a new building, a new school building, which is going to open in 4 years. And by design, the science labs are going to be interspersed throughout the school. It's not going to be, there's going to be a science section and a history section, but all the classrooms are going to be multi-purpose, so that you have a science lab next to an English class, next to a history class, next to a world languages class, as a way to promote interdisciplinary learning. So we're going to see how it goes.
That's great. Congratulations.
This is kind of just to add on to some things, but also to ask a question, if I may. One, the failure. I actually have a sign in my room that says the only way to pass this class is to fail. And it's nice because once you have the kid who must have an A, and they walk in and they look at it, and you could just see their face go white. But eventually they understand. We also work with UConn. My district also works with University of Connecticut's College of Engineering, and every year they sponsor us in both the Moon Rover race and, oh my God, I just forgot it, the Rube Goldberg device. And just out of curiosity, how many people here participate in the national competition for Rube Goldberg? Do any of you? You should. You really should. This year's competition was open an umbrella, and if it's a concrete rubric. You'll get X amount of points if you do it in 10 steps, more in 20, more in 30, more in 50. Our kids did it in 53 steps, and you get more if you have an artistic component. And by one point, they had Mary Poppins, where at the end, a little Mary Poppins, one of the little tiki drink umbrellas opened up, and a little Mary Poppins floated up and flew away, and it was perfect. They had chimchimery going, and so you should really try it because it gets the full interaction, and there's no way they have to learn how to fail. They have to learn the interactions of everything, and then I tell them to explain the physics behind it. So something to think on.
That's great. Thank you.
I teach junior high, and I've always tried to have inquiry and project-based learning in my class, even during the No Child Left Behind intense, let's test and get everything right years. And my solution to balancing content with inquiry and constructionist-based learning in the classroom is I've made instructional videos, even though, yes, you're right, absolutely, just make the kids read the book. But I totally agree with that. But what I've also experimented with is integrating a quiz right after the video that's online that goes tied directly to my gradebook. So I can see, what they learned. And then also using Articulate Storyline. This is a program that allows you to make HTML files and SCORM packages. You can create interactive learning situations where you can set up a situation either through video or just text and images, and then have the students give a dynamic response. They can do multiple choice answers, they can fill in their own text, they can drag and drop, they can select an item, and then based on how they respond, you can have then video response. Or whatever response you want, that then leads to a branching tree of a whole series of ways that students are interacting with curriculum. And so that's been my solution for content because I guess I'm uncomfortable as a science teacher completely letting go of some robust content delivery and making sure that they actually got it. And so this way, slowly over time, I've been creating these lessons that I can just post on their electronic gradebook and say, this is your assignment, you must do this. And so if they don't have a computer at home, they go to the library, they spend 30 minutes, they watch probably about 15 minutes of content that I've delivered, but then 15 minutes of it roughly interspersed is them responding to what I have given. And if they get it wrong, then I coach them electronically on how to get it right. And then their score goes directly into my gradebook. And I can set it up for them to repeat it if I want, as many times as they want until they get 100%. And so they're very motivated. And I really think it's a wonderful learning tool for them because then they want their A+ for this. And it's really like an effort-based grade, but they've learned. And so it's been really helpful, but it takes a lot of time to create these.
Great. Gail has another comment.
I worked with my daughter, who volunteers at her son's elementary school, and we set up a data in the kindergarten. We had them sliding things down a string with a paper cup with paper clips or something in them, marbles, I believe it was. And one student would be in charge of the marbles, and one would count them out loud as they put them in, and one would go to the board and write the number under their group. And one they didn't know how to time yet, so one would count how long it went down. Another one would go to the board again and put the number in. Essentially, when we were through, they had a data table on the board, and they were able to make comments such as, it didn't matter how many marbles were in. It took the same amount of time. I said, inertia.
Very good. Yeah, very good.